Okay, again, keeping in mind that I am not an expert on AI, ML, and so on, but as a climate scientist, I must keep track of what's happening because I do use AI for doing many things like downscaling forecasts uh, to scale for sectors like agriculture, food, water, and so on and so forth. So here, this is a nice report that just came out end of last year, so just about a year ago, on artificial intelligence for climate change mitigation. I tend to be behind on doing these because I have a lot of good material I keep collecting, and then I keep recording podcasts when I find time, and I keep falling behind. Okay, this is from Innovation for Cool Earth Forum. You can look up who they are, and obviously they are good people. uh, just the top blurb in terms of the summary of the report. It's good to start by reading this because now we know where we are headed with the report. It's a fairly long report. As brief as I can be, it still will take few podcasts, I think. AI could make significant contributions to climate mitigation. Areas of special opportunity include greenhouse gas emissions monitoring, the power sector, manufacturing materials innovation, the food system, and road transport. Obviously, this has overlap with the few podcasts we already have in this stream of AI for climate or climate change, and it's okay. Here it gives a bit more specific information on sectors like the power sector, manufacturing, material innovation, food system, road transport, which are very important for managing emissions and climate solutions, decarbonizing, etc. Barriers to AI helping reduce greenhouse gas emissions include the lack of trained personnel and access to high quality data. Data should actually come first because without data, AI is nothing. All institutions with a role in climate change mitigation should prioritize AI skills development uh, and explore ways to develop and share relevant data. So this can cross national boundaries, so we may need global policies on data sharing and openness, etc. And we have also discussed already open source codes and so on. Risks related to AI, of course, including bias, privacy, and safety issues, require careful attention when AI is used to reduce emissions. Also discussed a little bit, so we'll just touch upon it again. Greenhouse gas emissions from computing infrastructure for AI are currently modest. The amount of such emissions in the years ahead is highly uncertain. So sustainability of AI itself is critical in terms of reducing its footprint. All government agencies with responsibility for climate change should create an artificial intelligence office with responsibility for assessing opportunities, barriers, and risks with respect to AI in all aspects of the agency's mission. So that's a specific recommendation. We already talked about key concepts in AI, so this report also gives a little blurb on what is AI and what it does or how does it work. So AI is the science of making computers perform complex tasks typically associated with human intelligence. So we try to make computers think and create information, synthesize information and data like our brain does. So here is a visualization of a deep neural network, a type of AI model that powers popular AI systems such as ChatGPT, which you may have heard of, very extensively used now, and every big corporation like Amazon, Microsoft, Google, Facebook, Apple have their own versions of AI. So you can see there are you're starting from somewhere, going into some layers, and then coming out on the other end. So you can think of input data and output, and then we talked about supervised learning, unsupervised learning, large language models, and so on and so forth. Modern AI relies on a branch of computer science called machine learning. Machine learning refers to a set of algorithms that detects patterns from large and sometimes messy data without explicit programming, i.e., without a human crafted description of each pattern. So you give it a few rules like the deep neural network, and it learns from the input data, finds patterns, and then tells you what's happening. So it's doesn't require any physics Navier-Stokes. You just give it data and it tells you what's happening. This task this is a task often associated with human learning, for example, learning to walk, speak, or identify objects. So many people have very skeptical or view, maybe cynical view of AI, saying how can it do something we don't tell it to do well. When you are born with the hardware and the software, and you watch and learn. Nobody's telling you to walk or crawl or speak. You just learn because there is generic code that tells you to do that, and AI works in basically basically a similar way. How does AI differ from traditional computation? Consider a computer program that plays chess. The traditional approach to building such an algorithm involves explicitly programming the rules of chess, encoding basic principles of good gameplay, and specifying a method to search over all possible moves to pick the best one. Even in a game as seemingly simple as chess, this is an enormous task for a computer. The number of chess positions is about the same as the number of atoms on Earth. For the curious, that is about very long number. No existing computer, even the most powerful supercomputing clusters, can efficiently play chess this way, because you are looking at the chessboard and making computations in your head, and let's say your brain is limited in how many computations you can do, whereas the computer can do much more than you can. So can it always beat you? Well, this is the game that keeps going on about who can beat the computer, and this has gone on for a couple of decades now, right? So AI differs from traditional software in its requirements and outputs. So traditional software and AI, no historical data needed for traditional software. Historical data or simulator is essential for AI. Explicit programming domain knowledge and no training needed. Everything is explicitly programmed. Whereas for AI, implicit programming of expectations of patterns from data, and need to train the AI algorithm to extract patterns. So when you give it input, supervised learning will tell it what to look for, whereas unsupervised learning just goes on a fishing expedition. Outputs here would be deterministic results and can efficiently solve simpler problems. We are being a little bit brief in the way we are saying it, but doesn't matter. Statistical results in AI can sometimes make mistakes, and AI can offer solutions to more complex problems than simple traditional softwares can. Okay, so here is data, model, computation, and here is how the brain works as well. Keeping humans in the loop is essential to using AI to solve real world problems. In other words, you don't want AI to go crazy off on its own, but you want to have some humans in the loop. And there is a big debate about whether AI can take over the world and start controlling us, or start nuclear wars and so on and so forth. So AI systems work by using a model to identify patterns in data. Models by themselves are not useful and must be trained on data through computation. Computation integrates the idea that AI systems do not contain explicit information. Rather, computation is the mechanism by which AI unravels and leverages implicit patterns from data. So you just have data that could be a mix of physical variables, socioeconomic variables, audio, visuals, blah blah blah. Then it tries to do these things, and there are many details. We are being very brief and superficial here, and I'm being even briefer than the report itself. Okay, so large language models and the future of AI. We already talked a little bit about this in the key concepts, but worth repeating. Large language models such as ChatGPT are one type of AI system. LLMs analyze vast amounts of text data and can string together responses to queries by predicting the most likely next word in a sentence. So it learns by looking at lots of structured text, and then learns the grammar, learns expected structures of sentences, and stays ahead of you. So when you start typing, it can provide the next string of words already based on what you are typing. The user interface is similar to conversing with a human, expanding the potential user base for such technology to anyone who can type a question into a computer. The success of these systems has revived questions around the future capabilities of AI. ML and AI experts are divided on the transformational potential of LLMs and the best balance between rapid innovation and caution. So if you train it this way, and can it go off and do something on your own? Be sentient. This is the key word. Can it have its own conscience? and then do things that we don't like, right? And secondly, how much data is needed for AI? We say data is very critical and essential. The answer to this important question depends on the resolution of the problem AI is solving. If you are thinking about the weather problem and you need data globally, then if you start collecting data at a kilometer scale, you get some huge amount. If you want to go to 500 meters or 100 meters, it keeps increasing exponentially. In just the number of moves in each game is in a data set has no effect. The resolution of the task is at the game level. The more games, the better. In other words, it keeps on watching the games and learns from that. In time series tasks, if a common event is being studied, a few days of data may be sufficient, but for rare events, years of, if not decades, of historical measurements will be needed. So if you are thinking about return period of a heavy rainfall event or a flood event or a cyclone, then it needs a lot of data to get trained. In general, data size is not a useful metric. The amount of data to drive successful AI applications can range from megabytes to terabytes. Okay, so you can think of it this way in terms of data availability and accessibility that are key aspects of enabling AI applications. The ideal zone for AI development relies on accessible, measured, and well digitized data. So even if you give it an image, it has to be digitized, obviously, right? Computer deals with digital data. So here you have data availability, measured and well digitized, but here measured but poorly digitized, measured and not digitized, or not measured at all if you go in this direction. Here if you go to internal inaccessible data accessibility issues, if you go here, data may be accessible at cost or could be open source. So here is the ideal zone for AI, where you have open source data and it is measured and well digitized. Very schematic, but makes sense. So let's look at the executive summary of the report before we go to the next topic in this report. We'll start with chapter 1. So basically I'm going to take some material from each chapter. There are 12, I think, and I'm going to read the executive summary after I describe the most salient points. Because it's a long report, I'm not going to read all of it, obviously. Chapter 1 is on Introduction to Artificial Intelligence. It's already something we talked about, but we'll repeat again just to re-emphasize. Artificial intelligence is the science of making computers perform complex tasks typically associated with human intelligence. Modern AI relies on machine learning, a type of software in which algorithms detect patterns from large data sets without being explicitly programmed. This differs from traditional software, which requires explicit programming of domain knowledge. AI instead relies on implicit program by using historical data and simulations to train the models to extract patterns. Access to large, high-quality data sets is important for complex real-world applications of AI, and in this context we will look at climate mitigation. These data can come from various public and private sector organizations. Tabular or time series, geospatial, and text data are all commonly used in AI. Data must be properly measured, digitized, and accessible for AI applications. The release of ChatGPT in November 2022 generated extraordinary public attention to AI. ChatGPT quickly became the most rapidly adopted product in human history, with more than 100 million users by January 2023 within 2 months. The website now receives roughly 1.8 billion visits per month. Large language models, such as the ChatGPT, are one type of AI system. Okay, so the second chapter is on climate change issue that we have to deal with. So we'll look at that a little bit and summarize it, and then see how many chapters we can cover in each podcast. So this is about 15 minutes, which is good enough. So we are again in AI for climate mitigation. So we'll look at the introduction to climate change, then emissions, and then move into sectors in terms of decarbonization and how AI can help. Okay, see you in the next part of this report. Okay.